Hi there, and welcome to this video. This is the practice set for writing equations of lines given slope and any point, but specifically using slope-intercept forms. So there will be other videos that will get into how to do this using, say, point-slope form and other ways that we might write equations of lines, but this video is going to focus on using slope-intercept form. Give this video a like if you find it helpful. Drop a comment or a question below. Let me know what you think. If you have further questions about something that I do or talk about, and subscribe to the channel for more math help. Pause the video to work these problems on your own, and then come back to check your work. So for this first problem, we are looking at a line with a slope of 3 and going through the point -1, -4. And I mentioned this in the lesson video that goes with this, but you'll see the that verbiage phrase like different ways. So goes through, containing, passes through, the point -1, -4 is on the line, are all different ways of saying the same thing, meaning that if you plug in -1, -4 into the equation for this line, it will make it true. So we are starting with the slope-intercept form, and we know that the slope is 3, and we are given this point -1, -4. Now, what that does is it gives us an x value and a y value to borrow. Okay, we are not keeping those in the problem. We are just borrowing those. We are going to give them back. So over here, I'm going to plug in y is -4. The slope m is 3, x is -1. And what that means is that the only thing in this equation that I don't actually know is the y-intercept. And because the point -1, -4 will make this equation true, I know I can use that point to figure out what the y-intercept is. 3 times -1 is -3. And then we will add 3 to both sides. -4 plus 3 is -1. -3 plus 3 is 0, giving me my value for b. So now I have a value for b and I have a value for m, which means that I have everything I need to be able to write the equation. So we're giving back that -1 and that -4. We do not keep them in there. And this will be y equals 3x minus 1. You could also write 3x plus -1 if that helps to remember that subtraction is really adding the -1 there. So that's pretty much the whole process. Make sure that you are giving back the x and the y value. I have had a lot of students over the course of the years do something like this, where they'll tell me -4 equals 3 times -1 minus 1, which is true, but also not the equation of a line. It's just a true arithmetic statement there. So that might be your check to make sure that this works, but it's not the equation for the line. The equation for the line needs to have the x and the y back in, because the line is not just the point -1, -4. It is all of the points that make that equation true. Moving on to the next one. This one, I swapped up the verbiage a little bit. So this just says containing 6, -1. But the strategy is going to be the same. So we have our value for m. We need to get a value for b so that we can plug it into y equals mx plus b and have the equation for the line. So coming over here, we've got the point 6, -1. Our x value is 6, our y value is -1, and we are going to borrow those values. So y is -1. Our slope is 1/2. Our x value is 6. And we're going to use that to figure out what the b is. 1/2 of 6 is 3. You could think of that as 1/2 times 6, or 1/2 of 6. Okay, 6 divided by 2, all different ways that you could look at that. And that is a 3. And then we'll subtract 3 from both sides. -1 minus 3 is -4. And now I have my b value, and I can write the equation of my line. Y equals 1/2 x minus 4. There we go. All right, next one. Next Next one has yucky numbers. And if you watch the lesson video, I do talk a little bit about some of the strategies that are open to you here. Remember to separate your arithmetic from your algebra. So the algebra is, do you know the mechanics of how to take this information to write the equation of the line? The arithmetic is, can you navigate the fractions? Do you have, or do you make sign errors? And we do want to split those two up because sometimes students will have a very solid grasp on the algebra and actually kind of trip up on the arithmetic and will misunderstand that and think, well, I'm just really bad at algebra. No, your algebra skills are fine, but we might need to work on the arithmetic. So let's go ahead and see how this one goes for us. So we have the slope of 1/3, and what we need there is the y-intercept so that we can write the equation of the line. We are told that this passes through, again, a slightly different way of saying that, the point 5, 1. So we have x is equal to 5 and y is equal to 1. So figuring this out, we're going to do the same thing we did with the others. Y is 1. The slope is 1/3. X is 5. And we're going to use that to find b. 1/3 times 5. We multiply straight across, that is 5/3. And unlike the problem that I did in the lesson video, this one does not convert nicely to a decimal. This is a repeating decimal, which means that at some point you would have to round it or truncate it in order to continue on with the problem, because you're not going to write like 0.3333333 like forever. Okay, so mathematicians will tend to steer away from that because we want everything to be precise. But the algebra mechanics here are going to be the same. We are going to subtract the 5/3 from both sides. So essentially we have 1 minus 5/3. If you have access to a calculator that will do fractions, you can dump this in as is. You just need to know how to use the calculator to do it. Most calculators will do this, including some very basic scientific calculators. Problem is that sometimes you're not allowed to use a calculator. So I know some exams have calculator and non-calculator portions to them, and you might encounter this in a portion of an exam where you don't have access to a calculator. In order to add or subtract fractions, we need to have a common denominator. In this case, the denominator that we want is a 3. So the way we go about getting that is we take the other number and we multiply it by the denominator over itself. So in this case, 3/3, which is equal to 1. 1 times 1 is still 1. And so we will have 3/3 minus 5/3. And that gets us our common denominator. 3 minus 5 is -2. So the y-intercept is -2/3. And now I have what I need to write the equation. Y equals 1/3 x minus 2/3. Now you might be thinking, ugh, well, that's awful. That would not be good to graph. That's true. The y-intercept there is -0.66666, repeating forever. So you'd have to estimate where that is. But there's also no rule in math that says every number has to come out nice all the time. And you just want to be aware of that. And if you had to graph that, this would be a good one to bust out a graphing calculator or a Desmos utility or something like that to be able to graph it. Right. Last problem here. You are training for a half marathon. Each week you add 1.5 miles to your long run. After 6 weeks, your long run is 12 miles. Write an equation to model this scenario. What was your starting mileage for your long run? And where do you see this represented in the equation? So let's take a look at this. So we are told you're training for a half marathon, which is awesome. I completely support that goal. That's one of my favorite distances. After 6 weeks, your long run is 12 miles. And so you've got those two numbers that kind of go together. Typically, you would put time. If you do have a time value, that will be your x. And then the other value, whatever that is, that would be the y. If you watch the video for this, it was money. In this case, it's miles. So we'll say after 6 weeks, you are running 12 miles. That's your long run, stretching it out. Now, the rate of change is the 1.5 miles. And then it's not like 1.5 miles, like the rate of change is miles per week. And that's kind of indicated over here where it says each week, you add 1.5 miles. So the slope here would be 1.5 miles per week. That's always going to give you some kind of rate of change. And if you need to go back and watch the video on what slope is and how slope is represented, it might help clear that up. So your slope will be incorporate both the rise and the run. So you got the rise over the run. So the rise is going to be in miles and your run is going to be in weeks. And together those numbers are going to give you miles per week. So let's go write the equation. Y equals mx plus b. We are using 12 for the y value. We are using 1.5 for the slope and 6 for the x value. 1.5 times 6, what is that? That is 1.5 times 6. Like, I have it on a piece of scratch paper. 9. I was like, I have it on a piece of scratch paper over here. I record the video and blank out. That's 9. And then we'll subtract 9 from both sides to get b is equal to 3. So we have the slope is 1.5, the y-intercept is 3, and so we have y equals 1.5x plus 3. Now, what some people might do here is they might swap out the variables. So instead of x and y, they might say, well, my y value, that was mileage, and so, or distance. And so they might say that's d, and my x value, that was the number of weeks. And so they'll just swap out the variables a little bit on that. And you can do that or not do that. That is up to you or up to the directions for a specific problem, just whatever floats your boat there. Now, let's take a look at the graph for this. Guys, so we got the graph there. I still have a little bit of writing on that. But let's take a look at how that's represented, because the graph and the equation, like all of that is just different ways of writing the same thing. So we have weeks on the x-axis, long run mileage on the y-axis, and what we were told was that after 6 weeks, our long run was 12 miles. And what you could do in a pinch, okay, is you could go back and say, like, my slope was 1.5. So you go down 1.5, back 1, down 1.5, back 1, down 1.5, back 1. So you'd have to do like negative over negative, and you could actually work your way backwards and find the y-intercept. So the other question that we were asked there is, what was your starting mileage for your long run? In other words, what was your long run at the point that you started your training? And that would be 3 miles. And where do you see this represented in the equation? Well, it is the y-intercept. And what you'll see after like a long time of doing problems like this is that your y-intercept is very often the starting value. I'm not going to say 100% of the time is your starting value, but very, very often, if you are asked what is the starting value or the starting amount of money or like whatever, it will be the y-intercept. And what you can see is that gradual climb of every week, you are increasing it by 1.5 miles. So after the first week, you're going 4.5, and then after 2 weeks, you've gone up to 6 miles. Now, in reality, if you were really training for a half marathon, it doesn't typically go up like that. And what you'll do is something that actually looks more like this, where it'll go up and then you'll do what's called like a step back week. Usually when you get to about 8, you'll do this like step back week where you'll step it back to 6, and then you'll jump back up and you go up, and then you'll jump back down. And that is to give your body a rest. If you just keep piling on miles and miles and miles and miles, you actually end up getting injured. And so that might be an interesting graph to explore, or the relationship between that and people that study exercise and the benefits of different training programs. You better believe that they have graphs and equations that are looking at this, and maybe they'll look at how injured people are, whether they finish their training program. So there's a lot of really interesting questions that you can ask with that. Were these problems helpful? If they were, give this video a like and drop a comment to let me know. Subscribe for more math help, and I will see you in the next video.